Awesome. Good afternoon, Prague. I'm very happy to be here in Prague for the second time, and I have to tell you, this city is awesome, very beautiful. I'm always amazed for coming here. My name is Edson Yanaga. I'm a Director of Developer Experience at Red Hat, and today we're going to talk a bit about revisiting Effective Java in 2018. I don't know how many of you have read first or second edition of the book? Okay, nice. Third edition? Some of you? Okay, so, well, Effective Java, I consider it to be one of the books that shaped my career. So maybe some of the knowledge that is available in the book, if you read that and you apply that in your code, maybe you can upgrade your career from an associate to a senior or even a principal developer, because that's very nice content. And has been some years since the second edition of the book, but luckily for us, the final of the last year, Joshua Bloch was able to release the third edition. He was able to update that with some code from the latest versions of Java. So that's what we're going to discuss today. Of course, the book is very big. There are many different tips from that. I'm just picking some of my favorites and presenting some of the new ones that are available in the book. So that's the main concept of this talk. My Twitter handle is @Yanaga, and just in case you're wondering, I'm a Brazilian Japanese. I'm also happen to be a Java champion, a Microsoft MVP, and a TDC Rockstar, which I believe to be a very unusual combination. And since we are here on this big room, I have a special surprise for you. I brought with me this very nice Chromebook. I picked this one myself, which doubles as a tablet too. So it has a touchscreen interface, and I'm going to run a raffle in the end of this talk. So after the questions, we'll have a raffle. And the rules are you have to follow me on Twitter @Yanaga. You have to tweet a message with a picture of the session. Mention my Twitter handle @Yanaga with the hashtag GeeCON. Okay, so I'll draw all of the tweets with the following these conditions, and I'll shuffle them, and I'll pick the first one to be the winner. Deal? Okay. I don't know. Well, you don't seem that excited, but it's a very nice Chromebook. Okay. Okay. That's a $400 Chromebook, so it's worth something. And okay, picture hashtag GeeCON. Mention @Yanaga and follow me. If you forget my hashtag, I have this on the t-shirt too. Next tip. I don't know if last time I was here I had already published the book, but I released this book from Riley, Migrating to Microservice Databases, where I discuss how can you get your old legacy monolithic relational database and maybe later migrate and integrate your microservices data. So this is a distributed data book. You can get the full electronic version of the book in this URL, thanks to Red Hat developers that bought the royalties of the electronic version. After the release of this book, which was a year and a half old, I continued my research. I have many other topics that I was not able to cover on the book. I have some talks on YouTube discussing that, and maybe I'm thinking about writing another book with the new things that I'd uncovered. But that's the current content that we have. And we're going to discuss, of course, third edition of the book, this very nice book. I was able to get, I pre-ordered that. I got on the end of December the printed version of the book. And I was able to get Joshua Bloch to sign himself when I was in France. So I have a signed copy, which I'm pretty sure it's in my home, but I couldn't find it before coming here. So to put that thing in my bag to show you, but you have to trust my word on this. Okay. Another great book. You see, great concepts are widespread, so many of the good concepts that were brought from Effective Java can also be applied from domain-driven design. So immutability, some concepts that are around Effective Java are also around domain-driven design. So this one I consider to be another great book for you to read. Another book that shaped my career. And if you think about architecture, distributed systems, microservices, or even monoliths, domain-driven design is a highly required skills these days. People are looking for architects that can apply domain-driven design well in their systems. So that's another great read. Even though I believe to be a hard read, There are other books from Val Vernal, like Implementing Domain-Driven Design, which are great, great reads. I have some different opinions about that, but that's just particular opinions. All of the books are great. And what we have new in the 3rd edition of Effective Java, basically we have some tips, some concepts describing lambdas, streams, optionals, default methods and interfaces, try with resources. And we're going to try to cover this and also try to cover some of my favorites, tips from the Effective Java book, like factor methods, try with resources, equals, hash code to string comparable. And if you wonder what are these numbers are the exact numbers from the book. So if you open the book and I want tip number 11, it's going to deal about hash code, so you can follow the book later too. Minimize mutability, and my favorite one, enums. That's what we're going to try to cover today. And it's going to be I'll have to speak a bit fast, and I'll try to do, of course I'm nervous, because we'll try to do everything with live coding, but enough of talking. I have some slides later too, but we have to do some live coding. Just let me mirror my screen. And okay. So is it big enough for you? Good. Okay. So let's try to start. I want to minimize mutability from my phone number class. So let's try to add some properties. Of course, try to minimize that. I'll add some properties, which will be final. Of course, number 2. Then I get to initialize them on a constructor. And I don't like constructors particularly. You can read the reasonings for that on the Effective Java book. But of course, I'll apply refactoring and get that with a factor method. Some of the benefits of using a factor method is that first, factor methods have a name. The disadvantage of using that is that if you create a Java doc from your code, the Java doc for the constructors gets a separate section, whether constructors only have a single, it's just like another static method. So that's maybe the only disadvantage. But you can have many different names from your constructor. I like off, but if you know that you're always creating a new instance when you call your factor method, you could call that, like, for example, new instance. If you know just get, if you're getting from a cache, could be get to. So you have many different options of doing that. Another great thing great thing about factor methods is that you're not required to always create a new instance of your object. Suppose that you have a very complicated object initialization in your constructor or in your factor method. So maybe if it's expensive to compute that, you could cache the instances, and every time that somebody gives you the same parameters, you can always return the same instance. If you always return the same instance, you have the benefits of being able to use the equal operator instead of the equals method to provide some comparisons, because that's always the same object. If you want to know how can you implement the fly with pattern to always return the same instance, one tip that you can look at the source code of the big decimal class. If you use value off, you're always returning. There are some cached instances, the mostly used ones, they're always cached. You can return them. What else? You're not required to always return the same type of object. So suppose that you have phone number now, but later you need to create an international phone number and local phone number. So we could create subclasses of phone number for now, but later maybe it should be even better for us to create an interface. So I transform that to a phone number interface and then provide different implementations of the factor method. Now it's even better, since in Java 8 I can have like static methods on interfaces. So your code will be much more easily evolvable later. Okay, so you can change, you can put an if here. Well, if area code is greater than something, maybe that's a local number. Maybe if area coder is like starts with something, maybe that's international phone number. So you can provide different implementations. At least, for example, different formatting. Different countries format their phone numbers differently, so you could provide different implementations of that. That's one of the reasons you might want to use a factoring method too. Okay, and I also like to check all of the arguments here. I'm going to use a library which suppose that area code needs to be greater than 100, and maybe check that number needs to be Number needs to be dated in thousands. So that's some of the conditions that I can give. And that's one of the another tips. You should try to check the values very early in the process when you try to create an instance of the object, instead of whether when you're trying to get the values later. Sometimes you get null pointers, sometimes you get like invalid states, because you're only checking the values when you're using that, or you're not checking that at all. So if you try to check the values when you're creating an object, for example, in this factory method, you have an early check. So whenever the user is trying to provide you the values to the system, you're already validating that. I think I have other talks on YouTube where I show how can you integrate these with nice frameworks like, for example, Hibernate, JPA, and JSF, or Spring MVC. So, but I'll stop here because we're just discussing effective Java. Okay, so that's one of the reasons for using factory methods. If my object is immutable too. A comment about using Guava. Some people love it, some people hate it. I'm between both ends. I love it because it's a very nice library. I hate it because of the incompatibility issues that we have in the past. If you've ever been broken by the fact that, well, I want to use library X, but it uses Guava 15. I want to use library Y, but it uses Guava 20, and they're incompatible because some methods are missing from the new version. And sometimes, in some very corner use case, the behavior changes, which is even worse. It compiles, it runs, but the behavior has changed. So that's why many people argue against using Guava, Google Guava. But I saw a thread on the Guava mailing list, and I believe that beginning from version 21, they decided to fix these incompatibility issues. They'll be much more conservative, like the JDK. They will stop breaking backward compatibility. I didn't test this feature in the past couple of years. So if anybody has any comment about that, I would love to hear that later. Okay, but you can use. You can't. If you want. If you want to. If you don't want to, you can use other libraries too. And now if I'm using an immutable value object, I need to provide a very nice implementation of equals. I also, if I'm implementing equals, I need to implement hash code. And a very quick implementation of that could be if instance of phone number. I can get phone number other, receive an object, and I want to cast. I could be doing this. That area code, other.area code. And objects equals this dot number, other dot number. Okay, this is a very nice implementation, very easy if you don't care about performance. The problem with this implementation is that we know that area code and number are primitive numbers. So if you're using here this method requires objects, so we're boxing and unboxing every time you do the comparison, which is a very costly operation. That's one of the reasons for you to not be doing that. But if I know that's a primitive, I should be using the equals operator. So this area codes equals other dot area code. But if there are objects, you should be using this because it tests automatically for nullability. So you won't have issues here. Also, I can provide false. If I'm using hash code, I could, if I don't care about performance again, I could be using this dot area code, other dot this hash. Code, this dot number. Okay, and here I have two problems. Again, the boxing and unboxing problem. These are primitives. I have to box them as integer classes. And the other problem is that a hash method requires a var argument, which means that every time I'm calling this method, I'm creating an array, which is an expensive operation too. So if you want this code to be performant, and remember, maybe most of the time you shouldn't be caring about performance unless you hit a performance problem. You could use your IDE to automatically generate a hash code method, or else you can read the book. Joshua provides a nice implementation of a hash method for you too, which is fixed. But again, if performance is really your problem, maybe if you know that your class is immutable, you should not be calculating the hash code every time you call the hash code method. Maybe you could be just initializing that. I could, for example, provide here a private into hash code. And if I want to use that, maybe I could just initialize the value here. Okay, so I just return the hash code if I know that the properties won't change after it gets initialized, right? Another optimization that I might have when I'm using equals, if you know that it's equals going to be extensively used in your code, you can equals to this, return true. Right? If I'm comparing against myself, if you're using a lot of sets, hash sets in your collection or tree sets, not tree sets, if you're using just hash sets, maybe you want to use this optimization, okay? So that's some of the considerations that I have using around equals and hash code. Also, if you're using these methods, you should be providing a toString method. And the comment about that is that toString is not supposed to return business values to the user. If you want to format something, there are other methods for that. toString is something that is useful for you if you want to debug your application. You want to know what's happening with your code. You should provide something here with toString and a nice implementation from Guava to toString. You could create this, then add, well, I want to say that area code is area code, and add number, and toString. Just for you to be able to see, I want to create a method here just to show what happens. So if I create a phone number of 999-1234, and I decided to print it as a toString, then let's see. That's a pretty formatted operation. It exposes the essential information that you need from the phone number class, its internal state. So it's easy for you to debug, or if you want to log this information, it will also be useful. Okay. But what if I want to print that to the user? Well, there's another interface in Java, which many people don't know about, which is Formattable, which is the one I recommend to use if you want to print. You can internationalize, you can localize everything here. So just to use the formatter, I'm going to say, well, maybe I want to separate the area code from the number, and I'm going to use this. Okay, you have many flags and options here. You should need to read the Java docs because they're very extensive. But if I want to print that, maybe instead I want to print F. I want to say that I want to format the code like this. And you see the difference between the two formats. This is a business value. This is a debugging information. Okay, toString just for debugging purposes. And another tip that I have to give you regarding the internal information is that if you're using this internal information, area code and number, to provide something to outside your class, for example, providing a business string to the users, you should also provide, in this particular case, getters for this information too. I advocate against using getters without knowing exactly what you want. For example, I would never provide a get hash code method for that. But if you're using these values in a string, you should provide also getters for that too. Why is that? Because if you're providing these values as a string, I'm pretty sure that if somebody needs the area code, for example, they will get the formatted string, they will parse it, and they will get the three first characters from the string to get the area code. So if later your business requirements change and you decide to change the string, everybody is screwed because they're parsing the string. So in this particular case, you should be providing getter information because it's already externalized in your class. Right? So we covered toString, format to area code number. What else can we do? Well, phone number, if you're sorting phone numbers in your system, maybe it should be a nice thing to implement comparable. So I want to implement comparable on phone number. And how do we do that? So comparable is a tricky interface. In the past, I could use with Guava again. My favorite implementation would be to create a comparison chain. .start. I want to compare this area code, this area code. Then I compare again this .number, .number, and I get the result. This was my favorite implementation before Java 8, but now that we have Java 8, we don't need to rely on Guava for doing that. We can use the own JDK classes for providing our comparator implementation. So what can I do? Well, I can just use comparator dot. Now that I know, since I know there are primitives, I can use the compare and int. I can use a very nice lambda here. And I can say, well, I want first to compare the area code. Then I want to compare, area code. Then I want to compare the number. And then I want to compare this and the other one, okay? So I can return this different implementation here. And the downside of what I'm doing is that every time I'm running the compare method, I'm creating a new comparator instance. So, and you guess, comparator is stateless and it can be reused. So instead of doing this every time, maybe I could refactor this code. Refactor, extract, constant. It could be a phone number comparator. And now I have this nice constant here, the phone number comparator, and I just have to call it every time I want to run a comparison operation. That's a much more efficient way of implementing the comparator interface using just the JDK classes, right? I hope you're enjoying that. So that's the basics that I wanted to cover for now. Let me check my time, not much time. So let's get back here to code. Java 8 added to Java functional interfaces. So if you want to use Lambdas, if you want to use your own interface into Lambdas, you can create your own functional interface, even though most of the times you don't want to do that. But if you do create, maybe one of the tips that I can give you is that if you want to, if you want to create your own functional interface, okay, my functional interface, and I want that to be an interface. And I say that, well, public void do something, which is one of the worst possible interface that I can create because it returns nothing and gets no parameters. So it's very stupid. But so you shouldn't be creating interfaces around that. But I should, if I want to create a functional interface, I should annotate that with @functional interface. Why is that? Well, you don't need that. You can use this interface in Lambdas right now. With the requirements that you can only have one single method that is abstract. You can provide other default methods for your code. But the problem is that sometimes you're creating a library that is going to be imported in other projects, and you're cool with that. But people will start using your functional interface, and later somebody is maintaining that code months later after you left the company, and they decide, well, this is not a functional interface because it's not annotated. Let's just add another method. Do. Other thing. Guess your library compiles because, well, you're not using Lambdas inside your own project, but when you update the library and everybody bumps to the new version, their code is broken because they were using that as a functional interface and you broke the contract. Now it's not a functional interface anymore. If you add this annotation, your code won't even compile, okay? So you should always be adding functional interface, especially if you're creating code that is going to be used by other people than you or your team, which is usually the case. But even if you're not creating libraries, you should be doing that because, you know, code lives for like 20 years. You're probably not going to be the one maintaining the code in 20 years from now. Oh, hopefully not. Yeah, I don't know. Or hopefully yes. Maybe you can regret the choices that you're making today. And back to slides. And another great change that we have with Java 8 Lambdas is favor strategy over template methods. I'm pretty sure that most of you are very aware and very used to this strategy design pattern, template method design pattern too. Particularly template method because that's a solution that we have for some common problems to avoid some copy pasting. So in the past, if I wanted to have to solve a problem doing this, well, I have here a template class. And it used to be, well, I need a method that does do something, but maybe I want to there are some steps that I need to be doing before, and there are some steps that I need to be doing later. So, but right here in between, I need to switch implementations between my classes. So what do? You used to do like template something. And you created this method as an abstract method. So it's going to be protected abstract void template. Okay, so if I'm using template, maybe It needs to be an abstract class. So if you wanted to modify the implementation just on that template method, I would create subclasses like class specific implementation extends template class. And I would have to implement this method. I would use, well, C. And if I had another implementation which just changes this implementation here, I would just say D or something else. That's the traditional way for us to avoid copy and pasting code, where the beginning and the end of the method are always the same. That's what we used to do before Java 8. Now that we have Java 8, there's a better approach for doing that, changing to the strategy pattern. So I'm going to create a strategy class. And just to be fair, I'll try to, template class. I want to copy this method here to my strategy class, so we can have the same methods, which does nothing. But instead of calling a template method, I will say that, well, I want to, let's say that I want to get a string here, so I can final producer string producer. It's not producer, it's supplier, sorry. I want to create a supplier, and I want to add a constructor parameter, and of course I want to refactor that to a factor method, as you've seen today. So here I have a supplier implementation. Instead of using here a template method, I'm just going to say, well, supplier, did I say producer? Oops. So nice to have these IDEs these days, right? Supplier.get. So if I want to run that, I can just use, well, let's create a main method. I can say, well, I want to have a strategy class off, and I want to create a supplier, and supplier is going to provide you this string as a lambda. And if I run this, oops. Of course, I didn't call to do something. It's doing nothing. And here you can see I changed it from a template method to a strategy pattern. And this way is much more flexible. And you have the added benefit of being able to use Java 8 lambdas. Your client code will be much more beautiful if you agree with that. Okay. So that's another challenge. So since I'm talking about lambdas and functional interfaces, first reasoning about functional interfaces is that you rarely should be creating your own functional interfaces. And why is that? The JDK already have enough functional interface which covers most of the cases. It's very unusual for you to be requiring a specific functional interface. And whenever you add another functional interface to your code, you're just increasing the coverage area that that other programmers need to learn to use your code. So if you just stick to the basic functional interface from the JDK, your API will be much easier to learn and to use. Okay. And last time I counted on the JDK, they had like 39 different function interface, and you might be thinking, "Oh, that's a lot. Should I have to learn all of these 39 interface?" I think it's more now that we have Java 11. Well, the answer is no. If you just stick to these 6 functional interfaces, you have most of them covered, if not all of them. And why? Because you have unary operator, which receives an argument and returns an argument of the same type. And which are the variations? Well, you have int unary operator, you have long unary operator, you have float unary operator. So most of the variations of the interface are just to cover the basic types from Java for performance reasons. So if you know that a unary operator is something that receives a parameter and returns the same type, you have covered in all of the other ones. If you want a basic one, a basic type, you just add int, long, float, double, and other types in front of that. Okay. So you also have binary operator, which takes 2 parameters of the same type and returns the same type. You have predicate, which takes something and returns true or false. You have function, which gets a parameter and transforms that to another type. You have supplier, which creates an object from nothing. And you have consumer, which takes a parameter and returns nothing. These are the basic types that you have on the JDK. And if you learn that, you'll be covered for most of the cases. Okay, that's what we have to learn. Oops, not just that, I have more. Okay, so let's try to cover here, how can we use these lambdas and things? So now that we learned about function interfaces, lambdas and function interfaces, let me try to get here. Oops, I didn't delete this code, sorry. So we have we are using lambdas, but we have a shorter version for using these lambdas. We call that method references. And method references usually are more readable than just using the lambdas. There are some corner cases too, but most of the times, if you know that your lambda could be converted to a method reference, you should be using a method reference. And in Java 8, you have 5 different types of method reference that you can create, and I'm going to cover and comment all of them right now. Okay, so first one is the static method reference. So if I have a code and I want to provide something from string to integer, maybe I can say, well, integer, I can say I'm receiving a string, and I can say integer.parseInt s. Okay, that's how I would do that with a lambda, but I can convert this, and most IDEs, they can convert automatically these days between lambdas and method reference. I can convert that automatically to integer, parse int. And once you get used to the syntax, the method reference is much easier for you to read. It even requires less characters for you to type. Okay, so this one should be more readable than that. What else? You also can have a bounded predicate. So let's see, when I have a bound predicate, I could say, well, I have an instance. I can say instance now is after instant. Okay, so this is a way of using lambda. I'm using this lambda because I'm getting this object from this method. In this particular case, now is always creating a new object. Okay, but it didn't have to. You could be just returning the same instance every time. I just want to say this is bound because I'm always calling this is after method on the instance that is being returned here from this method. Okay, and how can I convert this lambda to a method reference? Well, I can do this instant.now colon is after. Okay, and I have to warn you, I have the discussion many times already. These two implementations are not bytecode equivalent, but I'm just showing that you can transform. How can you transform a lambda to a bounded method reference? Okay. So, and that's why the IDE can't automatically convert between the two different implementations, because these implementations are not bytecode equivalent. Okay, but it just sometimes it's useful. You're getting these objects from this method now, and you're calling this method is after on the instance that is being returned. That's a bound method reference. You can also have an unbounded method reference. For example, I'm receiving a string, and I want to say I want to call lowercase on the same string that I'm receiving. What if I want to convert that to a method reference? I'm just saying that, well, string colon to lowercase, and that's unbounded because I don't have a specific instance in which I want to call the method. I'm taking whenever argument string argument that I'm receiving as a parameter, and I'm calling to lowercase on that specific instance that I'm receiving. Okay, that's an unbounded method reference. I can also have a constructor method reference. This one requires me to create a new tree map. So I could say, well, if I want to construct, I'm starting from nothing, and I want to return to you a new tree map. But if I want to turn that into a method reference, I could just convert that saying tree map colon new, which is a very nice syntax, well, my opinion at least. And you can also create arrays. So if suppose that you're receiving here an integer, which is the size of the array, you could say, well, new int I. But if you want to use the array, the method reference, you could be using int brackets colon new, which is a very nice syntax for creating an array too. Okay, these are the 5 different types of method reference. You should always be trying to use this kind of method references, unless the method reference is bigger than the lambda. Some corner use case, for example, well, suppose that I have this class and I have this method reference could be a very big name. Let's say that if I want to refactor with a lot of characters. Suppose that you're getting some classes from Spring, you get like 256 characters from one class, and you want to call that in your code, and you want to use like, well, let's use a method reference. But if you're using just here, I could say static test. If I'm just doing this, I could say, well, let's just call test. Okay? It's static. I need to create a lambda. But just for you to have a type, because I'm running out of time, instead of just calling the method, I would require to use my method reference test. Okay, if the lambda was valid, you see, this version using a lambda would be much bigger than using a method reference because the class name is big. So you use your judgment to call when you should be using one or the other. Okay. What else do I want to show? I want to show you enums and what changed with the functional interfaces in Java 8. So let's create an enum called operation. Okay, operation. Okay, suppose I want to create before Java 8 up to Java 7, if I want to create an operation with add, subtract, multiply, and divide, I could say that, well, maybe I can create a public abstract int apply, int x, int y. And I would require these different enums ints to implement differently each one of the apply operations. So if I had add, I could say, well, apply. And I could say, well, add returns x plus y. If I want to subtract, maybe I can say that, well, this one return x minus y. If I want to multiply, say return x times y, and this one apply return x divided by y, and I could give a arithmetic operation exception. Okay, so this is the basic implementation, which I believe to be very nice up to Java 7. Now that we have Java 8, we have a much more nice way of implementing that, of course, using lambdas. So what if, instead of providing these implementations into each different instance, I could just create, well, I want private final, I want to create an int binary operator, and I want to create a constructor for that. And I want to say that instead of doing this, on the constructor of the enum, I want to provide my operation. How do I do that? Well, I have an int binary operator. I'm getting 2 ints, x and y, and this operation returns x plus y. Subtract 2. I'm getting x and y, and I'm getting x minus y. This one, I'm getting x and y, x times y. And the last one, don't worry, it's red, but I know what's the problem. X divided by y. Okay, this should be enough. It's complaining because I still have this apply operation in its abstract. So now I want to implement this operation apply if I don't want to change the external interface. Okay. So what do I do now? Return operator dot apply as int x and y. Now I have an equivalent implementation, but again, it's a subjective matter. But I believe this one to be much nicer than the other one. Okay. Agreed? And operations. And another thing that we can add here to my operations, that sometimes the operations that I want to modify between my different instances is not as simple as just using a lambda x plus y. That's where we can use, for example, more method reference. Suppose that the add operation is a very complicated operation and it can't fit in a single line, or else it can't fit like in a couple of lines, 5 lines, 10 lines. So you should be, and in fact, both, all of them, add, subtract, multiply, and divide, are very complex, very big operations. Maybe they deserve their own class for each one of the operations. What could you do? Well, in this particular case, suppose that addition, new class, addition operation. And maybe I want to implement my int binary operator. Interface, and if I implement that, apply as int, well, maybe it returns x left plus right, but in between you should be doing a lot of these very smart things. So, but now you want to call this operation inside your enum, which is this one. So add, instead of doing this, you could be, well, maybe I can addition operation dot dot apply as int. Oops. Oh, I shouldn't be implementing because it's not static. Okay, and here in operation, now it works because that's a static method reference, which we just learned on how to apply that. And you could be using all of these use cases here too. Okay, that's my tip about using enums for your operations. Okay, and another benefit of using enums, and I have to repeat that, if I want to create a singleton class, you know, many people still use that idiom, private static final singleton instance, and maybe some people even instantiate that here, which the problem with doing that is that you don't have single instance guarantee inside the same JVM, because if you're using serialization in your class, for example, if this class is serializable, you don't have this guarantee. So if you want this guarantee, once your class is serializable, you need to implement your own serialization proxy. You have like a lot of pages on the Effective Java book describing how can you properly implement your serialization proxy, which is not fun, but sometimes you have to do. But if you want to create a singleton for free using just plain Java 5 plus code, you should be using an enum. And instead of doing all of that, you just use an instance. Okay, so everybody can get your code and say, well, I want to get the singleton instance, and it works. Okay, and many people forget that enums are full-featured Java classes. You can add your states, internal state here. You can add your methods, your instance methods, your stacking methods. You can do anything that you do here in your class. That's very useful and a very nice tip if you want to provide singleton implementation. That's why enum is one of my favorite constructions in Java. And if you ever know a C# developer, whenever they see the enum implementation in Java, they get amazed, because in C# enums are much more like constants. You don't have all of this power. But when Joshua Bloch implemented enums in Java version 5, he decided the enums should be full-featured classes. They just should have like a different syntax for implementation. And that's what we have today, and that's why it's so powerful. Okay? And that's what I wanted to show you for... Let me see if I forgot something. Okay. And that's what I quickly wanted to show you for now. Of course, I recommend you to read the full version of the Effective Java book. I recommend you strongly to buy the book, because that's something that you'll be revisiting over and over time. Even after more than 10 years, the first edition, I still keep like reading some stuff from Effective Java, especially when I want to implement some different things. For example, serialization proxies is not something that you do every day, but when you need to implement something, you just go to the book and learn how you should be able to do that. Okay, and if you have, and all of these components is or will be available at developers.redhat.com. I would love your feedback, and if you have any questions, I'm available for you. Thank you very much. No questions? I must have done something wrong or right. Yeah. Of course, everybody wants the Raffle, but I still have a couple of minutes.
I just want to ask, what is your opinion about using libraries like Lombok?
Sorry?
What is your opinion about using libraries like Lombok?
Okay. Yeah. I've used Lombok in the very first versions of Lombok. At that time, didn't work great for me. But I have to tell you that it was, I don't want to count the years, but maybe was almost 10 years ago. And I realized that libraries like Lombok, they're doing a very great job these days. I didn't comment about that, but we have other implementations for if you want to create these immutable objects, you want to create equals, hash code, and getters, and everything else. You could use projects like Auto. You could use projects like Immutables, which is the one I've been using in the past couple of years. But Lombok, in my particular opinion, but I'm not the usual person. I hope Lombok developers are not here. I don't like this kind of generated code, but that's just because I'm picky. I know many people that use and works great for them. And I just don't like, I prefer to watch the code and inspect the code. And this type of auto-generated code is not on my particular taste, especially because in the early years of Java, these tools never worked greatly. But I know that many things have changed in the past years. And I know many people are using that successfully. And my advice is that if it works for you, great, keep using. If, like me, you're an old, grumpy guy, you don't like that, maybe you have other options. Okay? But I'm not that old, okay? Anything else? I think that on Twitter, in this case of Stephen Colliburn from the J.Time library, from the new Date and Time API 2, I think he tweeted me something. He has his own library for creating and generating these equals hash code implementations. Especially, I think he was watching my session when I was doing it live, and I made a mistake in the equals and hash code, and he corrected me on the fly through Twitter. And he suggested, use my library. So you see, there's a lot of different libraries for you to be preventing, because one of the things that I completely agree with you is that implementing equals hash code to string the way I did is very error-prone. And if you think that that's too stupid for you to create a test class, you're wrong. So even if you're implementing equals hash code and everything else, you should be creating your class, your own test for doing that. Okay.
Is there something you will do differently than Joshua Bloch suggests?
Oh God. In some cases, I might have different opinions. It doesn't mean that I'm right. It also doesn't mean that he's wrong. But I don't want. I don't know if I want to start flame war right now. But yeah, we can discuss later. But it should be a long thread. If you could, I would love to discuss something like on an email thread. I think you have more time. You can be more complete. Would be nice. Just like I have some disagreements, if I can say that, with even Eric Evans or Von Vernon on how should be you implementing some domain-driven design concepts. I do that too. And I think it's healthy to have different opinions. That's how we grow. And sometimes I've learned that in the beginning of my career, most of the times I thought I was right, and of course I was wrong. And now that I'm more experienced, most of the times I think I'm wrong. And then sometimes it happens for me to be right. So I think that's how you evolve. Okay. Any other questions? Okay, I think now it's time for the raffle because we're... Oh, a question? Quick one? The mic's coming.
Does method references have better performance than Lambda?
Oh, the question is if method reference have better performance than Lambda. And I'd say that they're bytecode equivalent, at least on the cases that I said so, okay? So on the bounded one that I showed, they're different. So there might be a performance difference, but on the other ones, it should be the same. It's just a syntactic sugar. Okay. Thank you. And let's go for the Raffle. So what I did here, you can see my screen. I'm going to increase. Here, I have a service. You have to trust my implementation. Okay. But the source code is open source. Okay. So you just have to trust that the source code on GitHub is the same that I run. And I have here a service on my website, which basically will filter. I have two parameters. The first / is the hashtag that I'm filtering, GeeCON. I hope you have applied that. And the second one, Yanaga, it just checks if you mention my Twitter handle and if you're following me. Okay, so it collects a lot of them. Then it filters the distinct tweets. So if you tweeted a lot, thank you very much, but it only counts as one. Okay, and it will get the first 20. It will get all of the tweets. It will randomly pick 20, and it will sort them. So of the 20 tweets that I'm going to show, the first one is the winner. Deal? So the same rules apply. I'm just telling the implementation. And let's see how it works. And the winner is Mike G something. And let's say if he tweeted something nice about it. Okay, cool. So Mike G is here. Okay, congratulations. And again, thank you very much for attending the session. If you want to know more about advanced deployment pipelines, I have another session in another room, and I'll be able to show you more content around it. Thank you very much.